Today, I'm going to explain what lake effect snow is, how it forms, and why it's especially common in the Great Lakes region of the United States. Lake effect snow is a mesoscale weather process that occurs when cold, dry air moves across a much warmer, unfrozen lake surface. As this air passes over the open water, it undergoes rapid changes that ultimately create narrow but very intense bands of snowfall. These events can produce several inches of snow per hour and are responsible for some of the heaviest snowfalls in North America. These events are very common in the eastern region of Lake Erie and the eastern region of Lake Ontario as well. The process begins with the temperature contrast, or gradient, between the lake surface and the air above it. The Great Lakes tend to stay warm year-round, which is a big factor of why lake effect snow is so common in this area. Typically, we need a difference of at least 13 degrees Celsius, or about 23 degrees Fahrenheit, between the water temperature and the air at around 850 millibars, which is roughly 1,500 meters above the surface. When the air is much colder than the water, heat and moisture transfer from the lake into the atmosphere, and this becomes extremely efficient. The temperature difference between the temperature of the Great Lakes and the air is greatest in November and December, which is where lake effect snow events happen most. As cold air flows over the lake, it picks up heat and evaporated moisture. Because this air mass is initially very dry and much colder than the water beneath it, the heat and moisture transfer happens extremely quickly, creating ideal conditions for rapid cloud development. This warms the lowest layer of the atmosphere, making it more buoyant, and it begins to rise. Once the air rises and cools again, the added moisture condenses into clouds, often into tall, narrow convection cells similar to miniature thunderstorms. Within these clouds, snow crystals develop and grow. As these crystals are continuously lifted and recycled through the cloud, they collide and clump together, allowing the snowfall intensity to increase even further. Next, the wind plays a crucial role. When the wind blows steadily from one direction, the air travels the full distance across the lake, what we call the fetch. A longer fetch gives the air more time to absorb moisture and heat, allowing clouds to grow deeper and produce heavier snow. Once these clouds reach the downwind shore, the uplift caused by hills or subtle elevation changes can squeeze out even more snowfall, creating localized but extremely intense snow bands. So why do Lake Erie and Lake Ontario get the most lake effect snow? There are several reasons. First, these lakes tend to remain unfrozen longer into the early winter season. Lake Superior is colder and often freezes earlier, and Lake Michigan and Huron, while productive, have different wind patterns that don't consistently focus snow on population centers. Lake Erie and Lake Ontario sit farther east, so they are more frequently aligned with cold westerly or northwesterly winds that come in behind passing cold fronts. Their east-west orientation means that when wind blows from the west, the air travels the full length of the lakes, giving them an exceptionally long fetch. Lake Erie is shallow, so it warms quickly in the early winter and stays relatively warm compared to the cold air masses moving over it. This makes it especially efficient at producing lake effect snow early in the season. Lake Ontario, in contrast, is very deep and retains its heat longer into the winter, which helps it continue producing lake effect snow later in the season. Understanding lake effect snow is crucial because these events can have rapid, severe impacts on urban communities located downwind of the Great Lakes. Unlike typical winter storms, lake effect bands can intensify with little warning and drop several feet of snow over a very narrow area, overwhelming plow crews, shutting down major highways, and stranding residents and emergency responders. Cities like Buffalo, Cleveland, and Syracuse must plan specifically for these localized but extreme events, as they pose risks to transportation, power infrastructure, and public safety. By studying how lake effect snow forms and behaves, meteorologists can better forecast dangerous bands, and urban planners can design more resilient systems to protect lives and keep essential services functioning during these intense winter outbreaks. conclusion, lake effect snow forms when cold, dry air crosses a warmer lake, picks up moisture, rises, and produces clouds that dump heavy, localized snow on the downwind shore. Lake Erie and Lake Ontario are particularly prone to these events because of their east-west orientation, long fetch, relative warmth, and the presence of downwind high terrain that boosts snowfall even further. It is important in understanding these extreme snowfall events to help local cities prepare for extreme